Welcome to The Explainer. You know, when it comes to software, there's this age-old tug of war, right? Do you build something totally custom, or do you just get something working, and get it working fast?
Totally. And that custom route, it can be a real minefield. Super slow, crazy expensive, and honestly, pretty risky. So today, we're going to dig into a powerful alternative that's really become the go-to for a ton of projects. It's all about integration and configuration.
So, here's how we're going to break it down. We'll kick things off with that core developer's dilemma. Then, we'll jump into what's being called the reuse revolution and the 5 key steps that bring it to life. Of course, we got to do a reality check, the good and the bad, before we look at why this whole approach is pretty much the new standard.
All right, Alex, so let's start right there. With that dilemma, when a company says, hey, we need a new system, what does that old school, build it from the ground up way of thinking actually look like?
Well, the traditional way meant, you guessed it, writing every single line of code from scratch. And that immediately puts you at a crossroads. Are you really going to pour a mountain of time and money into a completely custom build, or is there a smarter, more efficient way to get there?
And that from-scratch approach, it's not just about being slow. It's really risky, isn't it? I mean, the costs can just explode, and you hear stories where the software ends up costing way more than all the computers it's even running on.
Oh, for sure. And that's exactly why this whole reuse-oriented idea is so powerful. It's a completely different path, one that's specifically designed to be faster and, easier on the wallet, because you're using pieces that are already built, already tested, and ready to go.
Okay, so that brings us to the reuse revolution. What does that actually mean? How does it work? You know, the easiest way to think about it is just don't reinvent the wheel. Seriously, let's say you're building a race car. You're not going to go mine iron ore to forge your own engine block, right? No way. You'd find the best pre-built engine out there and integrate it into your chassis. Then you'd hook up a laptop and configure the engine software for that day's racetrack. That right there is the core idea.
So, just to break that down, integration is like snapping the Lego bricks together, and configuration is about adjusting the settings inside those bricks.
That's a great way to put it. Integration is the how do we connect these things, the plumbing, and configuration is how do we tweak the settings inside them to do what we want. A huge part of this is using what are called COTS, or commercial off-the-shelf systems. Think about it. You wouldn't build your own payment processor from scratch, you'd just plug in a service like Stripe. That's a classic example.
And look, this isn't some weird niche idea that only a few people are trying. As our source material points out, for a whole lot of business software, this is now the standard way of doing things. It's become the default.
All right, I get the big picture, but let's get into the nitty-gritty. What does this actually look like step by step? How do you take an idea and turn it into a real working system this way?
Okay, so there's a pretty clear 5-step path. You start with specification, which is just figuring out what you actually need the thing to do. Then comes the fun part, software discovery. You literally go on a treasure hunt for existing tools or components that might do the job.
Right, and this is where it flips the old model on its head, because the next step is requirements refinement. So you might find an amazing tool and then actually change your original plan a bit to fit what that tool does really well.
Exactly. You let the available tools shape your plan, which is super practical. After that, you've got application configuration, getting that main system all set up, and then the grand finale, component adaptation and integration. That's where you get everything talking to each other and working as one complete system.
Okay, that process sounds almost too good to be true. It sounds so efficient, there have to be some catches, right? What are the downsides? You hit the nail on the head. It's absolutely a game of trade-offs. This isn't a silver bullet, and you really have to weigh the pros against the cons.
Well, the advantages are huge, and they're the reason everyone's doing this. We're talking massively reduced costs and risks. And the big one, you can get your system out the door way, way faster.
But then there's the other side of the coin. The biggest disadvantage is that you almost always have to compromise. Your final product might not be exactly what you first envisioned. And you lose control, right? The company that made one of your components could change it or even discontinue it, and you're kind of stuck.
That's the heart of it. You're trading perfect, custom-fit control for speed and lower risk. It's a strategic choice you have to make.
So, with those compromises in mind, why has this become the standard, especially for business software? It's simple, really. For most businesses, speed to market and cost savings are king. They trump the need for a 100% perfectly tailored custom system. Getting a good, reliable solution working now is almost always better than getting a perfect one eventually.
So, if we're going to boil it all down, the big takeaways are pretty clear. This approach means faster delivery,
way less financial risk, and it's absolutely a mainstream way to build business software today.
Yep. But the one thing you absolutely have to remember is that word, compromise. This whole game is about being flexible and adapting your vision to the amazing tools that are already out there, instead of forcing everything to be built from zero.
It really makes you wonder about the future, doesn't it? As we get more and more of these powerful, off-the-shelf building blocks, is the whole job of a software developer going to fundamentally change? And that's the big idea we want to leave you with. What if the future of making software is less about being a master coder who writes everything from scratch, and more about being a master connector, an expert at finding, integrating, and configuring all the incredible pieces that are already out there?